The broadcast is now starting. All attendees are in listen-only mode.
Hello and good afternoon. My name is Josef Strobel. I'm here at the University of Salzburg UNIGIS offices, and I'm very glad to welcome all of you to today's webinar. You can call it the U lecture or UNIGIS Continuing Education Lecture under our brand name as well. Thank you very much for registering and for taking your time today to join us to what I believe will be a very interesting and stimulating presentation. Very simply so, because the topic which is on our agenda today clearly is a timely one and a critical one for progress in the geospatial world. I will be glad to welcome Hans Viehmann from Oracle. He is now responsible for European, Middle East, Africa for what is called Oracle Spatial and Graph. People from the old ages like myself would briefly refer to this technology or to one of the cores of the technology to Oracle Spatial, and from the UNIGIS and University of Salzburg perspective, we have collaborated with Hans Viehmann for many, many years in this area. So I'm very glad that he has agreed to update all of us on the question of what happens in the areas of 3D and spatial databases from the Oracle perspective. I now have the opportunity to make Mr. Viehmann the presenter. He will share his set of slides with all of you. And before we get started, just a quick comment regarding possible questions you might want to ask. You do have your questions, your chat window in front of you, and we'd be happy to take questions anytime throughout the talk. But we will consolidate these for answering at the end of today's talk. We are looking at roughly half an hour, around 30 minutes of presentation. After that, we will take some time, and we'll leave it open how much we need for that, for answering questions. But again, you're welcome to ask these questions, put them into the chat window right away at any time during today's presentation. With that, again, welcome, and special welcome to today's speaker, Hans Viehmann, the Product Manager, European, Middle East, Africa. Mr. Viehmann, you're here?
Yes,
and
I am. Thank you.
The screen is yours. Please take it over.
Good. Thank you very much for the nice introduction, and also from my side, a very warm welcome to all of you wherever you are on this planet. A warm welcome from Hamburg in northern Germany, where we currently have fairly windy weather conditions. So if you hear some background noises, maybe related to a little bit of strong wind, which we have out here. Thank you very much for joining. It's a great pleasure for me to present our functionalities around point clouds, solids, and more on how to manage 3D data in the Oracle Spatial Database system. I apologize, I have one of these laptops which are more of a business and demo machine, which does not come with a webcam, so you'll have to live with my little photograph here. But then again, there may be the opportunity to meet me in person at upcoming events, for instance. As previously mentioned, I'm the product manager for what we call the location products, looking after Europe, Middle East, and Africa. When I say location products, what I mean is the extensions to our database which are capable of managing geospatial information, plus the map viewer technology for visualizing spatial data, and a couple of other things like workspace manager and so on. In my role as product manager, I primarily work with our strategic partners in the region, with key customers, with academia and research, and I have been following the activities of UNIGIS or actively participating in some of the university's activities over the last, well, almost 20 years, I would say. So it's a great pleasure for me to present to you this afternoon. Now, moving on to the topic of 3D data. In the past, I always used to think 3D data is great for making pretty pictures, and there were certainly some valuable and valid business cases back 15 years ago, but mostly the data acquisition back then was so expensive that many of the business cases would just not be viable. Now that has changed a lot over the last, let's say, almost 10 years, and we're now seeing a lot of applications and use cases in various business domains. For instance, in public services, we're seeing a lot of applications around risk management, determining floodplains or risk areas for landslides. Many of the activities, particularly in Europe, are geared towards the use of renewable energies. There are lots of city-wide applications in urban planning, be it traffic management, be it all sorts of other planning activities, and there are large-scale initiatives underway in various countries, sometimes on a national scale, if you look at Poland or the Netherlands, or sometimes on smaller scales. But also in the commercial area, there are a lot of new use cases coming up. For instance, in engineering and construction, where particularly site surveys are being used to monitor progress, or asset management is being conducted on the basis of 3D data. Now, to keep you awake, we have prepared a few polls, and for me it will actually be very helpful to have an idea of where you're coming from in terms of level of expertise and what your background knowledge is in this area of 3D data. So if you could let me know whether you just have a theoretical knowledge of 3D data and just background information about the use of 3D data, or whether you have actual practical experience with 3D data, or next level, even have been managing 3D data in databases, or even managing 3D data in Oracle Technologies. Now, I hope you can see the poll. I can't see it, so I hope you can see it.
Yeah, let me just step in here from the moderation point of view for a second. I can see that most of you, 80% of participants, already have voted. It gives us a very clear picture that the majority is in the area of being very, very curious. So only limited experience in today's audience, lots to learn, which is a wonderful situation. I'll give you a final second before I close the poll. This is exactly what I'll be doing now. So I close it and share it back with all of you. So you can see that 85% of today's participants fall into category number 1. 10% do have practical experience with 3D data management, but not in databases. And 5% out of today's participants do have practical experience with 3D data in Oracle Spatial and Graph. So I hope all of you had the chance to briefly take in this level of today's audience, and with this I'd be happy to turn it back over to our presenter.
Okay, well, thank you. And maybe if the few percent who do have experience of managing 3D data in an Oracle Spatial database already would send me their CVs, I'd certainly be interested. Now, joking aside, we can always keep in touch through the various social media. I'll come to that towards the end of today's presentation. Okay, so most of today's presentation I wanted to talk about the use of LiDAR data for 3D data acquisition. It has become a very widespread means of acquiring 3D data today, and it is a very powerful and very sophisticated technique to actually quickly gather information about really large areas. It's a technology which I cannot explain in greater depth just in the interest of time, but the fundamental idea is to make use of laser scanning and the reflection of laser pulses in order to determine the X, Y, and Z of any given point on a surface. You can do that through airborne laser scanning, through mobile laser scanning, or also fixed static laser scanning. And with every point you get a couple of additional pieces of information depending on the sensor, which can range from color to intensity to more sophisticated, like multiple returns and so on. Now, as I already indicated, this is a means of acquiring 3D data very quickly, and as you can imagine, for us as a database company, it's a brilliant piece of technology because it comes with massive amounts of information. These laser scanners are capable of generating like 500,000 points per minute, per second, and this can give you enormous amounts of information, which of course will need to be stored, pre-processed, analyzed, and then made available to further use. And I'll come to the ways we are using these kinds of information in just a moment. Given that most of you only have theoretical expertise around 3D data, still I'd be interested in what your specific field of interest is, because I have been focusing on 3D laser scanning data initially, but obviously you can use the very same mechanisms for seismic data, for bathymetric data, or you can start just conventionally with 3D data coming from CAD systems. So if we could now move on to the second poll, and if you would let me know which data source you personally would be particularly interested in, that would be very helpful for me to get an understanding of where you're coming from.
Yeah, I could already see that about 2/3 of you already have cast your votes. Apologies to all of you who want to choose more than one. This is a single choice question, so you have to decide which one is most relevant for you in your current set of tasks. I can see that LiDAR jointly currently with CAD, that's quite interesting, holding the lead, followed by photogrammetric and bathymetric data and seismic data sets being at the back of the field in the frequency of your votes right now. I think we are pretty much finished with mostly everyone having cast their votes. That means it's your last choice to make one selection. And while I'm now closing this survey and sharing it back with you, it's quite interesting, at least from my personal view, not being surprised about the lead of LiDAR, a bit surprised about CAD, but this is of course one of the core markets among others of Oracle Spatial and Graph. And again, bathymetric and photogrammetric data in the remaining 1/3, so after LiDAR and CAD, being in second place, followed by seismic data. I hope you had a chance now to take in this quick poll results, and with that, I'll take the chart away from you and turn it back over to Mr. Viehmann.
Okay, well, thank you. That was very interesting in terms of results on my end. In order to move forward, when we're talking about these kinds of 3D data, and no matter if they're coming from LiDAR data sources or from photogrammetric methods, or if you use seismic data. The key question, of course, is always how to make best use of the data you have acquired. And in the past, or up to a couple of years ago, many systems still used a file-based approach with the raw data. Only did a sort of one pass of analysis over the data, and then continued working with the results while leaving the raw data aside, which is a pity, because the raw data can be used in a variety of ways, not to mention the fact that the evaluation methods have evolved enormously over the last couple of years, meaning you can make much more, you can generate many more results from one and the same data set, which is expensively acquired, if you make the data available in a live form, let's say. And that's where databases come into play, which also have the benefit of providing the opportunity to merge or conflate the data from various sources. So you could use your LiDAR data, join it with your georeferenced raster data, or with existing 3D structures, maybe, which you already have from CAD or whatever other data source, and attribute data, which you find all over the place too. Also, if you want to do any kind of additional analysis, you don't necessarily want to run the analysis over the entire data set. So having the capability of quickly accessing some part of the overall data set is very beneficial, be it for processing, be it for visualization, and that's also where databases generally have their strengths. Apart from that, of course, mature databases, mature spatial databases, that is, provide a lot of fundamental functionality around what is generally known as information lifecycle management. Anything from data compression to data migration to cheaper disks or whatever. Plus, they have become pretty scalable, be it across nodes through clustering, or be it within single computing nodes through multiple processor support, so that you have a lot of compute power through parallelism available to you if you run on the appropriate software. The additional advantage of a database management system, by the way, is that if we're talking about large amounts of data, you don't really want to transfer this data across the network if you can avoid it. And if we're talking about, for instance, the well-known and well-documented AHN2 dataset, which was acquired by Rijkswaterstaat in the Netherlands, which covers the entire country, that's some 4.7 terabytes worth of raw data, point cloud data that is. You don't really want to push that across the network back and forth for any kind of analysis, but you would like to try to run any kind of processing as close to where the data sits, and that's also where database management systems certainly have their strength. Now, if we're talking about a 4.7 terabyte point cloud, or even if we're just looking at individual surveys, each of which provides a, let's say, logical point cloud, that in itself is a pretty massive amount of data, which on the one hand you want to manage logically, but on the other hand you want to break up physically to have chunks which you can actually handle for any kind of processing or visualization, let's say. And this is exactly the approach we, but also others, are taking for storing point clouds. There is a logical structure which contains the metadata, the footprint, for instance, of the entire survey, and that points to a more or less large number of blocks which constitute the entire point cloud, but which come in manageable chunks, which you can then use for analysis. And under the covers, the database takes care of both the physical storage as well as the access. Based on this kind of storage mechanism, now coming to the technologies we have actually implemented in our database, you can use the spatial technologies in our system to actually do a whole lot of processing already down in the database on the raw point cloud data. So once you've loaded the data, and there are different tools to actually load various formats, you can go ahead and turn, for instance, the point cloud into a triangulated irregular network, which in itself is a data type in the Oracle database, which you can then convert into gridded data in order to have a digital elevation model. Or you can do various other calculations on top of the raw data. You can extract geometries, you can do object recognition, or in the latest release you can also, for instance, calculate contour lines on raw point clouds, which can be quite useful, be it for visualization or be it for further analysis. One of our customer examples which I wanted to highlight here is the Austrian Rail Infrastructure AG, which is the part of Austrian Rail which maintains the railway network. What they are doing is they have equipped a special carriage with laser scanning equipment, which runs over every piece of track they own in the entire country once per year, in order to support particularly the maintenance processes. But they also use that for planning and construction. And what the customer does with the raw data is they don't only store the data in the database, but they also do a fair amount of object recognition in the database. So on the next slide, I've got a few screenshots that give you a bit of an idea of what the customer does. Customer is actually determining the profile of the track and is determining the position of various objects on or along the tracks. They determine where the platform starts and ends, or where poles are sitting, and so on. So all of that takes place down in the database, and the additional thing which they have implemented is OGC standards-based access to the data on top of that database. So this is what Austrian Rail are doing. There are a couple of things which I've just listed here to highlight things which we can do down in the database on top of these kinds of data, be it for visualization like pyramiding. If you're familiar with the concept of pyramiding for georeferenced raster imagery, then you'll immediately have an idea of what pyramiding is about for point clouds. This is something we can do for supporting visualization, such that if you look at a large point cloud from a distance, you don't need to transfer the entire point cloud to the client, but just a pyramid level to give you a bit of an overview idea, and then when you zoom in, you can continue loading more detailed data, just like you would in the case of raster pyramids. I've already mentioned contour line generation on point clouds, and once you have converted a point cloud into a triangulated irregular network, you can use that to determine the digital elevation model on a regular grid, for instance, which can be helpful to give you the ground level, which you can then use in conjunction with either extruded buildings from a cadastral map or CAD data to create city models, for instance. Okay, here's just a little picture of what it looks like when you generate these contours. In the interest of time, I'll skip to the next topic, which is how to make use of the additional functionalities around 3D data once you have processed your point cloud and generated additional information, additional objects from that. Because if you have a mature spatial database, you can use that to store and maintain not only point clouds, TIMs, and elevation models, but also 3D objects. Here are a couple of examples, and the most, let's say, convenient way, or particularly in city modeling, one of the most popular things which I'm observing at the moment is that people use what is illustrated on the right-hand side of this slide, namely they use the mechanism of extrusion starting from the building footprint, which they usually have from a cadastral map, in conjunction with an average height determined by laser scanning to at least determine a LOD1, a simplified block model of a building, to give you a bit of an idea of what the environment looks like in 3D. One of the customers who's actually doing that on our technologies is the capital region of Brussels. You can see a nice processing flow here, starting with the LiDAR data at the top, which they use to first of all determine the ground level. So they determine the terrain model, determine the ground surface, and then do additional filtering on the LiDAR data, merge that with building footprints, determine wall surfaces, roof surfaces, and then convert all of the data into a CTGML-based data model, which they then make available for visualization or further analysis, where they also include orthophotos and oblique imagery to have the textures on the buildings as well. If you're interested in that and you happen to be in Geneva early in May, you may want to come by at the Geospatial World Forum, where the customer is actually presenting that on May the 5th. So that actually brings us to the question of how to make use of these models. So once you've gone through this process, like our customer in Brussels has done, you end up with these 3D objects in the database, and just for the sake of completeness, I have added the topic of CityGML at this point. CityGML has become the standard really for sharing 3D data in a urban planning environment. Just to give you a bit of a background on this, the CityGML model, if you haven't been looking into that, is quite interesting in that it does not look at the 3D objects as, let's say, complete objects, but it structures the object semantically, meaning a roof knows it's a roof, a wall surface knows it's a wall surface, a door in the wall knows it's a door in the wall, and it knows which wall it is associated with, and so on. And that allows a fairly sophisticated representation of different levels of detail for buildings and structures in general. This can nicely be enhanced using georeferenced imagery for textures and facades. And if you want to get started with that, you may want to have a look at the 3D City DB, which is an open source data model. So it's not a product which is open source. It is a data model which is open source, which is being maintained currently primarily by the Technical University of Munich, a company called Virtual City Systems from Berlin, and MOS from Germany. But it's being used all over the place, and has gained quite some popularity. As it happens, that data model is available on Oracle Spatial and Graph, such that you can use it sort of straight away. One example where this was being used and where it really shows that it scales quite nicely is with the city of Berlin, where they have acquired data from some 550,000 buildings, gone through a similar process as the team in Brussels has, added textures from oblique aerial photography, and stored all of that in the 3D CityDB model, together with attributes and all sorts of things, and you can actually click on the individual buildings to get more details about the building, here in this case about the solar potential on the rooftop. There's a couple of tools available for 3D visualization and analysis on top of the technology I've just been mentioning, just for the sake of completeness. But you can also make use of core database functionalities if you have this kind of data in your database. Not sure if you're aware of the XML capabilities, for instance, of modern-day databases, but if you look at Oracle, for instance, we've had the possibility to publish data in XML, or store, manage, and publish data in XML form for many years, and you can very nicely use that to generate KML and make it available from within the database to applications such as Google Earth. So it's very simple to generate a model like this one straight from within the database. Right, and this brings us almost to the end. I'm slightly behind schedule, but only I think 2 minutes or so. Before we wrap up, I have a final poll prepared for you, where I'd be interested in what kind of application domains are mostly interesting for you. Just to check if you're all still there, could you kindly fill in the poll before we move on to the final few slides?
Yes, I'm glad to see that your voices and votes are already coming in. Let me at the same time take this opportunity to again invite any questions. We are coming already near towards the end of today's presentation, so if you have any general questions about today's topics or any specific questions with which you want to address one or another statement in the preceding slides, please write those questions into the chat window, and we will get back to these questions in a few minutes right at the end of the presentation. With this, I can see that a huge majority of all of you already have reflected on this question: which application domain for 3D data is currently at this time the most interesting for you. It seems to be a very clear lead for urban planning, so let me close the poll and share it with all of you. No telco representatives in the audience today, even more so from the energy, which we have pulled together with geology and exploration, a few people working in the asset management domain, and quite a few other, which we unfortunately don't have the opportunity here to specify. So on top of the list, urban planning, city modeling, 3D cadastre, and I would guess the second place actually goes to one of the applications within this domain, which would be the renewable energy topic, where we have seen the rooftop sample. So thank you, and I'll close that again as the final poll for today, and back to Mr. Viehmann.
Okay, yes, thank you, and thank you for your input. That was also quite an interesting result. So I hope that within these brief 30 minutes that I had, I've at least given you a bit of an idea of how to make use of 3D data within a database, or specifically an Oracle Spatial database, be it for visualization, be it for analysis, using a couple of examples. I hope it's become clear that the major benefit comes really from integrating the 3D data with existing 2D data and all sorts of other data available usually within the database, with the additional advantage of being able to do data processing in the database. I was talking about object recognition, about contour line generation, or converting 3D data to various outputs, management of and publishing of the data and metadata through open standards was something I at least briefly touched on. If you're specifically interested in that, that is certainly a very important area in order to make best use of the information which you have acquired and generated within the database. And finally, I hope I've at least given you a bit of an idea of what a database is capable of doing in that kind of environment generally. Now, in order to wrap up, just a few pointers to further information. Those of you who know Oracle probably know that we are freely giving away our technologies for academia and research, but also for partners and development purposes. So you can download all kinds of software from our Oracle Technology Network, and that's where you also find a lot of additional information, be it on our spatial graph database technology or on the visualization technology. If you then have any questions, like coordinate systems transformations in 3D and specifics around that, for instance, for that purpose, on the Oracle Technology Network you can find forums, one specifically dedicated to our spatial technologies, another one for map viewer. Just check out community.oracle.com and you should be able to find that. If you then would like to get in touch with, let's say, the larger community, besides events such as the International Oracle Users Group meeting in Washington in May, for instance, there is the possibility to keep in touch through the LinkedIn group. There are several groups actually, but the major one is the Oracle Spatial and Graph group, which has exceeded 1,300 members, and there are, it's become a bit of a replacement for newsletters. Really, there's a lot of information about current events and references and best practices and experience with our technologies and so on. Or if you're more into Google Plus, there is a Google Plus group as well, which is actually not maintained by Oracle, but by the International Oracle Users Group. So it's our users organization who are maintaining that. And that brings us to the end of my presentation. If you still have any questions, feel free to ask them in the chat.
Okay, thank you very much. This is Josef Strobel from Unigis Salzburg again. I'm very happy that we had actually a quite broad turnout of participants and attendees today. But first I would like to just express our gratitude to today's speaker, Hans Viehmann, for really managing to what I believed would be a seriously difficult and very hard task, addressing a topic like 3D in databases in a comprehensible and actually even in some parts well entertaining way within a very limited span of time. So congratulations for keeping everyone here on our toes. I think the mix of practical application examples, reference to domains, and a few glimpses into the back end of what's required on the database side with high volume data, with less than trivially structured data, was certainly great. Some of that was news to me, and I personally certainly was impressed by seeing what databases do today, because I think what you were showing in terms of analytical examples, starting from contouring, doing quite a few other analysis and visualizations straight from the database, this is not what we were used to expect from a database. So maybe I can phrase this comment into a bit of a lead-in question while I invite everybody else to come forward with your questions. Where are we going with all of this? Where very substantial analytical or transformative functionality is now being taken care of by the database. So spatial databases do part of what we were actually used to expect from desktop technologies.
Yeah, that's actually a very interesting discussion topic as such. I think this whole development is being driven by the sheer amount of data and the limitations which we tend to find on the client side sometimes. So if I look at our developments around point clouds in particular, we are focusing and will continue to focus on providing the data-intensive logic for those parts of the data analysis which particularly benefits from being done on the server side. Now, as we've been in this space, we as Oracle, in this space of geospatial data management for almost 20 years, we have obviously been working a lot with our partners, many of which are covering parts of the functionality, but the way this plays out at the moment from my point of view is that much of the heavy lifting in terms of data processing tends to be moving towards the server side, let's say, while the visualization and the more sophisticated analysis on smaller structures is definitely still a domain of the client side.
Mm-hmm, mm-hmm. Actually, one question we have here seems to aim at a contrast in the sense of we today, and we are looking at LiDAR data, have very high density data sets, and extracting information means reducing the volume of data available by modeling and other ways. How would Oracle Spatial and Graph support me when I have, on the contrary, very sparse data? So those could be depth soundings in borehole profiles, so geophysical data sets which are not that densely sampled, where of course we need to focus on interpolation tools before we can build up either subsurface surfaces or feature-based objects where interpolation is needed. Is there any functional support from Oracle for that?
Yes, the interpolation methodologies which I've been talking about in the context of point clouds, specifically turning even sparse data sets into tins, is something which is also available to sparse data. So for seismic data, just as an example. Now, whether that for the average geologist is sufficient is something which, with my limited domain expertise, I can't really tell, and I would actually assume that for some applications there are more specialized data processing methodologies turning, let's say, seismic data into subsurface models, but those, I think, can nicely go hand in hand with the technology I've been talking about, be it that they are implemented down in the database. I mean, you can use the same algorithms down in the database. The database is sufficiently open to also deal with that, or whether parts of these data sets are being transferred, extracted and then transferred to a client and then processed on the client side. We have an oil and gas customer that just comes to my mind in Australia, who are using these kinds of technologies to determine specific KPIs for their reservoirs, And that was actually a good example of where database technology with their scalability can come into play, in that they used to have reports which, if I'm not mistaken, were running of the order of 160, 170 hours, which went down to like 6 or 7 when moving to a new infrastructure. And that's one of the things which illustrates this scalability which you can which you can achieve if you use a multi-core, multi-cluster system. So just as a side remark on that one.
Let me go to the next question by one of our participants today. I summarize a bit, hope to fairly represent it. We use Map3D and Oracle Spatial in our office, but up to now we rarely do 3D projects with file-based data. So the question is there a white paper with sample data for a quick practical introduction to 3D with Oracle?
That actually touches on a very sensitive point, because it's one of the things which I still have on my to-do list. I am in the process actually of writing a paper on 3D. However, the paper alone is probably not really enough. You may want to start with something more practical, in the sense that you would rather want to have a, let's say, Oracle by example type of demo. I can check what I can make available if you get in touch with me directly, or the person who has asked this question. Feel free to get in touch with me directly, and I'd be happy to support you or deliver what may be required to get a bit of a jump start in this space.
Yeah. Actually, the next question sounds a bit like a follow-up on this one. This is where I pull it forward. It's a bit broader and essentially asking, are there any online independent learning opportunities made available by Oracle to dig a bit deeper into the subject? So that might be online courses, some kind of a virtual campus type of environment offered for continuing education, or just as a kind of technical online training which can be done independently online over the internet.
Yes, there are a couple of course materials available, some of which are actually only available for partners, which is actually not so much of a restriction, in that you can register as a developer on the Oracle Technology Network, and then they should be accessible to you as well. If there are specific, there are basic courses extracted from what we have as a 5-day instructor-led training, also available as online courses. Nothing specifically prepared for 3D at this point, but I was actually also thinking about doing something along those lines. So again, if the person who's been asking the question would get in touch with me directly, I'd be happy to discuss how we can move forward here, or whether we can make parts of the materials which we're using for our 5-day workshops, which obviously include a section on 3D, but which would be a bit sort of disconnected from the rest, available to help.
Okay, thank you. I guess from some of these answers we can really see how much at the cutting edge of today's technology we are here. But at the same time, it's of course wonderful to talk to the person who has some of this work on their personal agenda. So that means that we can look forward to having some resources available in the future there. With this, I will get to the...
Sorry if I interrupt you there. I just have a quick remark at that point. We are also preparing a workshop on 3D for the next Agit in July. So if you are thinking of coming to Salzburg in July for the Agit, there is the possibility of joining a session on 3D where there'll be more detail. And I'm still working with the German team who is going to run this workshop as to what this will look like in detail, but this is the current level of planning, so there will be the opportunity to learn more.
Yeah, no, that's great to hear about that, and thank you for mentioning. Well, we all appreciate independent online learning opportunities. I believe we all have made the experience that on-site, face-to-face learning, classroom-based learning can in many ways be more efficient and effective. So whoever has the opportunity to join us at Agit and GI Forum, yeah, thank you for that pointer. That brings me to the final question here on my list. So if anyone wants to come forward with yet another one, do so right at this moment. This question is a broad one, aiming at OpenGIS in the sense of OGC, and asking which ones of the 3D features are currently accessible with one or another kind of web map services. What's the policy and what's the current status of access to 3D data held in an Oracle geodatabase to be published via open specifications.
Okay, right. Well, that touches on a whole range of standards, and obviously 3D data from the Oracle database can be used through GML or KML in 3D form natively from within the database. That's the core functionality. If we're talking about the web feature services, that should actually work with 3D data, and the web map services would primarily be used for the 2D rendering. Anything beyond that, like making point clouds available through open geospatial standards, is actually a very interesting discussion, and if you would like to get more involved in that topic and have the chance to join us in Washington at our users conference in May, we will certainly be touching on that, and we are currently working with the academic community as well as OGC on further initiatives in that space. But this is futures, right?
Mm-hmm. Okay, thank you very much. It seems with this we have exhausted our current list of questions. This is not the end of the flagpole, as they say. Let me point out to everyone still present here that once you leave this session, you will have the opportunity to fill in a very quick 3-question survey. And one of those questions simply is if you have any further questions, and those of course will be forwarded and related to today's presenter. So if you want to make use of this communication opportunity, just take advantage of the survey you will be automatically presented with when you leave the session today. Yeah, with this I would like to again express our gratitude, simply say thank you, herzlichen Dank, to Hans Viehmann for doing this wonderful job of bringing together a broad range of high-end and advanced pieces of information in this brief, concise, and very informative session. We have made a recording of today's presentation, so if everything went okay, we will make this available online to our community and refer to that within the next very few days. I hope you all enjoyed being exposed to an advanced topic like this one. For me personally, certainly it was a good, again, learning and updating opportunity for myself to see what's going on at the intersection of 3D and databases. So thanks again to Hans Viehmann for presenting this topic to us. With this, I would like to conclude today's session and just point you to the next events, which again will be announced over this particular channel. The next speaker in our series of EU lectures will be Professor Jure Beinert, who is associated with ZGIS in Salzburg, but working with a US-based company. I believe and expect that databases will again play a substantial role, simply because Professor Beinert works with mass data from telecommunication and telco-based locations. So we are looking forward to this presentation in about 2 weeks' time. And again, we will send out information and details and registration offers for this. Thanks everyone for your attention. Special thanks to today's presenter. I hope it was a good experience for everyone attending today. Goodbye and good evening from Salzburg.